You're not stupid. All right, number one. So number one is here, or A, sorry. 2 coterminal angles. Most of you got this right. Add the 2 pi to get a positive. Subtract the 2 pi to get the negative. So 18 pi over 7 and negative 10 pi over 7. And then this is the one that you most commonly miss, the complement to the angle. So it's pi over 2 minus the angle, and that can't be negative. We would say there's none. Same thing if it was a supplement. Like if my original angle was 8 pi over 7, there's also no supplement. You can't have a negative supplement, okay? But this time there's a supplement at 7 pi over 7, or 3 pi over 7. And then D, convert from from radians to degrees. And you want to keep it as 720 over 7, okay? Again, you have to know how to go both directions on the quiz. Radians to degrees, degrees to radians. And then the last one said, find the arc length. I already gave you theta in radians. If theta wasn't given in radians, you'd have to convert first and then multiply it times r. And that you'll also keep exact. So you want to keep it as that one, 20 pi over 7. Questions on these before I move on? Okay. Then hopefully knowing your unit circle helps you with this. So like I'll even tell you when you're doing your quiz, the backside's your unit circle. Maybe flip to the backside, fill out your unit circle, and then go back to the other stuff. Obviously we didn't need it for section 1, but for a lot of stuff in section 2 you need it. So if you know your unit circle and you know your over 3s, right? The first thing I'm going to do is I'm going to take this and I'm going to convert it into mixed number form. So 14 pi over 3 becomes what in mixed number? 4 2/3 pi. Good. So then if I use my even odd trick, where's the evens? On the right. So 4 pi would be there. Then I look at my less than or bigger than a half. So is 2/3 bigger than or less than a half? Bigger. So it goes past the halfway mark and it's in the second quadrant. In the second quadrant, I have a negative x, but a positive y. And it's an over 3. So my coordinate point is 1/2 root 3 over 2. And that 1/2 would be negative. What's the tangent at that same angle? Do you remember? If it's over 3, what's your tangent? Go ahead, we root 3, and because it's in the second quadrant, it'd be negative. Okay.
Is it not easier to like just subtract 2 pi?
I mean, you certainly could, but the bigger that number, the more work you got to do to get to it. If that's at 37 pi over 3, you're not going to want to keep having to subtract 9 pi over 3, right? Yeah. All right, so then from here, we get our sine of t is the y coordinate, so it's root 3 over 2. Our cosine of t is the x coordinate, so negative 1/2. The tangent we just said would be y over x or negative root 3 if you memorize your tangents. And then to get the cosecant, we're going to flip sine, which becomes 2 over root 3, then rationalize it, so it's 2 root 3 over 3. To get the secant, we're going to flip cosine, so negative 2. And to get cotangent, we're going to flip 1 over root 3 would be negative, and then rationalize it, and it's negative root 3 over 3. Questions on any of those? So these could be literally any special angle, any over 3, any over 4, any over 6, any over 2, any whole number. And you'd be expected to find it. Positive, negative, doesn't matter. You'd be expected to find it. All right, then came your even and odd. Remember the two functions that are even are what? Cosine and its reciprocal function with secant. Those are the ones that don't change sign when the angle changes sign. So in this case, even though it said cosine of t is 5/7, cosine of negative t is still 5/7. And then to get the reciprocal, so this is the reciprocal of that one, it's just 7/5. If it's sine, cosine or cosecant or tangent or cotangent, we change the sign. So if I had instead said sine of t was 5/7, what would be sine of negative t? Negative 5/7. Okay, and then I said it already, this is not on your quiz for tomorrow because we just took the calculator part off. It will come back when you have to take your test. And you have to be in radians in this question because there's no degree symbol on that guy. So I would do 1 over sine of 5 pi over 7. And I get 1.279, 4 decimal places, so 1.2790. Questions? Okay, so everything that's on your quiz was basically on one of those two things. It's in 4-1, you've got to know your coterminals. So we're adding and subtracting 360, or we're adding and subtracting 2 pi. We had to know our complement. If it's in radians, we do pi over 2 minus theta. If it's in degrees, we do 90 minus theta. You need to know your supplement. If it's in radians, it's pi minus theta. If it's in degrees, it's 180 minus theta. You need to know all your, what else is from the first one? Oh, SOR. And theta must be in radians. And then we started to build our unit circle. We started with the quadrant angles. 0, 90, 180, 270, 360. And then we went in and filled in the radians. 0, pi over 2, pi, 3 pi over 2, 2 pi. And then we said closest to the x-axis was our over 6s. We said closest to the y-axis is our over 3s. And we said the in-between is the over 4. And in the first quadrant, we leave the numerators alone. They would just be pi. In the second quadrant, they are 1 less than the denominator. So 2, 3, 5, 1 less. In the third quadrant, they are what? 1 more. So 7 pi over 6, 5 pi over 4, 4 pi over 3. And in the fourth quadrant, they are? Good. 1 less than double. Or 5, 7, 11. And then we said let's start with the coordinate points at the quadrants. At the quadrants, this would be 1, 0. At the top, 0, 1. On the left, negative 1, 0. And on the bottom, 0, negative 1. Every over 6 gets the coordinate point of root 3 over 2 and 1/2. Obviously, positive and negative signs change. Every over 4 gets the coordinate point root 2 over 2 and root 2 over 2. And every over 3 gets the coordinate point 1/2 root 3 over 2. And then we added in the tangents. So tangent on the right and the left are 0. On the top and the bottom are undefined. It's root 3 over 3 for the over 6. It's 1 for the over 4. It's root 3 for the over 3. And in quadrant 1, both x and y are positive. Quadrant 2, negative x, positive y. Quadrant 3, both are negative. Quadrant 4, positive x, negative y. And those signs have to go on your actual coordinate point. So as you build in your coordinate point for the part that's for points tomorrow, you have to make sure you distribute in that negative the right spot.
Is there partial credit on that?
Yeah, it's not all or nothing. Yep.
Can you go back to what was on the...
So 4, 1, also you're converting from radians to degrees and degrees to radians. So radians to degrees, we do theta times 180 over pi. And degrees to radians, we do theta times pi over 180. And then if you build on your unit circle, so technically that was 4, 2. In 4, 2, we learned that the cosine is which part of the coordinate point? The x, the sine is? The y, the tan would be? Y over x. And then for all of these, we just find the reciprocals. Secant is 1 over x. Cosecant is 1 over y. And cotangent is x over y. So I will say people tend to mix these up too. Just remember that the c and the s never go together. So cosine goes with cosecant. Cosine goes with secant. And sine goes with cosecant. And cotangent and tangent both have the word tangent in it. I don't think people mess that one up. Questions on that? One more thing is the even odd. Okay, so even odd. We just talked about it. But cosine and secant are even, which means we don't change the sign. Whatever they sign they give you originally, if I change the negative on the angle, I still keep it. And then everything else, so sine, cosecant, tan, and cotangent are odd, which means if I change the sign on the angle, I do change the sign on the function. Yeah, it's not on there yet? Okay, so I'm going to start with the degrees. 0, 90 at the top, 180 on the left, 270 at the bottom, and it doubles back around to 360. Those are all degrees, so you'll put them on the little spots. Like you're literally getting back. Tomorrow's thing looks exactly like what you have. It will be all the lines that have the degrees. Then what's the pattern of the angles in between? 30, 15, 15, 30. So each of them has 3 lines. And there are 2 that are a little bit closer together. Well, 3 that are a little bit closer. Those are your 15s, if you need to remember it that way, okay? It's 30, which means I'm going to add 30, and I get 30 degrees. Add 15, 45. Add 15, 60. And then if I continue using my checkpoints, add 30, that's 90. I know I'm at the right spot. Add 30 again, 120. Add 15, 135. Add 15, 150. Add 30, I'm at the 180. Add 30, 210. Add 15, 225. Add 15, 240. Add 30, I'm at 270. Add 30, 300. Add 15, 315. Did I miss one down here? No, I didn't. Add 15, 330. Add 30, I'm at the 360. 1/3 the way done, right? Then comes all your radians. And on the right-hand side is 0 radians again. On the top is what? What's the radian at the top? Pi over 2. On the left, what's the radian? Pi. On the bottom, 3 pi over 2, or 1 1/2 pi, and we double it back around next to the 360 would be 2 pi. Then all the angles closest to your x-axis have what denominator? 6. Over 6. So this is over 6, over 6, over 6, and over 6. All the ones closest to your y-axis are what? Over 3. So over 3, over 3, over 3, over 3. And the in-betweens are over 4. Then in the first quadrant, it's just, well, they all have pi, but in the first quadrant, it's just pi. So it's pi over 6. It's pi over 4. It's pi over 3. In the second quadrant, what's the trick? 1 less. So the numerator is 1 less than the denominator. That means this would be 2 pi over 3, 3 pi over 4, 5 pi over 6. And it should make sense because we haven't hit 1 pi yet, so it can't be bigger than 1. It has to be less than 1. What's the trick in the third quadrant? 1 more. Now we've passed 1. So it should also make sense that our numerators are now bigger, would be bigger. So this is 7 pi over 6, 5 pi over 4, and 4 pi over 3. And then in the fourth quadrant, what is it? 1 less than double. 1 less than double, okay? Double would be 2 pi, so it makes sense, hopefully, that it would be less than that. So now it's 11 pi over 6, 7 pi over 4, and 5 pi over 3. If you can memorize 5, 7, 11, not 2, it's the same thing, okay? Okay, now every coordinate point that's at well, let's start with the quadrants. On the right-hand side, the whole reason this is a unit circle is because we moved to the right 1, we moved up 1, we moved left 1, and we moved down 1. So those are my quadrant angles. And then every over 6 has what coordinate point? Root 3 over 2 and 1/2. Good. Every over 4 has what quadrant point? Root 2 over 2 and root 2 over 2. Those are your 45, 45, 90 triangles, so it should make sense that they're the same. And your over 3, we reverse the over 6. So, oh, that's not 1/3. That would be 1/2 root 3 over 2. In the top right quadrant, they're both going to be positive. In the second quadrant, they're going to, x is going to be negative, y is going to be positive because we're moving back and up. Third quadrant, they're both negative because you're moving left and down. And fourth quadrant, positive x, negative y because you're moving forward and down. And then the last thing I said to memorize is your tangents. What's the tangents on the right and the left? 0. What's the tangent at the top and the bottom? Undefined. What's the tangent at every over 6? Root 3 over 3. Remember, it takes 2 3s to make a 6. And what's the over 4? 1. Makes sense because x and y are the same, right? And over 3? Square root of 3, because there's only one 3. So if you can memorize the tangents, it saves you the time of the y over the x. If you panic, take your y divided by x. You'll get the tangents. Questions? Okay, this is not one of those skills like you're learning for now and never use again. This is, I promise you, one of those skills that we will continue to use in this class all the way till the end of the year. Like we do polar all the way at the end and you have to know the unit circle, okay? And also any math class besides statistics, really, that you take, you'll see the unit circle again, whether it's here or it's in college. You'll see it again.
How many questions are on the quiz?
There's 9 and then the unit circle. But some have like part A and part B. So like
Calculator?
no calculator tomorrow.
Okay.
No, we'll bring it back on
The test.
the test because you need it for certain things, but not yet.
So we won't need to spend like exact